So u is 2x squared already. Then v prime means differentiate partially with respect to y of what you have as your v. And v is y cube, right? Plus v is y cube. Then u prime means differentiate partially with respect to y, because from the question it is with respect to y, okay? Of what? Of the u given to you. The u you represented as 2x squared. So you see how it works. 6y minus 12. Now here in this case, I will end up having 2x squared. Differentiate y cube partially with respect to y. So it's possible. That will be 3y squared. Plus differentiate 2x squared partially with respect to y is not possible. That will end up giving us 0. 0 times y cube will end up having 0. So this is how it works. Okay, so final answer gives us, multiply this and this together, you have 6x squared y squared minus 6y minus 12. Hence, del g del y, that is differentiating g partially with respect to y, we will end up having 6 in common, x squared y squared minus y minus 2. So this is for what? Del g del y. And you see the result here is totally different. Okay, is it this? The result we have for is here. For the x, we have with respect to x, we have 3x squared plus 4xy cubed plus 11, and this is different. So now we can go ahead and solve the next question. The next question here says that we should find the second derivative of g partially with respect to x. So b says that we should find del square g over del x square. Now here in this case, this simply implies that you have del over del x first. Then finally with what? Del g over del x. This is second derivative. Pick one of this outside. You know there are two. Then pick the second one, del x. The two products, del x times del x, gives us del square over del x square. That's what it means. That's what it means. So here in this case, we end up having del x of this result. I think I have this before, and that's for question A. The final result for this one, remember that we got, this is what we have. See what we have. Del g del x is 3x squared plus 4xy cubed plus 11. So then we end up differentiating this. Remember, should I still use the basic, or I should just go ahead and, let's go ahead and solve. So differentiate 3x squared partially with respect to x, so it's allowed. That's 6x. Now this one is product true, so I would advise you to just introduce a bracket and write v prime plus v prime to avoid mistake. This is the best way to do it. And then differentiate 11 partially with respect to x. You know, you can introduce x is power of 0 and is allowed as just 11. But possibly, do you have any other x to differentiate? This should be. And by the time you introduce x is power of 0, 0 multiplied, this should be 0. Like differentiating a constant as 0. So you should know what that means. Not 11. That's 0. So now I will need to introduce my product true. Remember that this is my u. 4x is my u. Y cube is my v. So my u is 4x. My v prime is differentiate y cube partially with respect to s. Is that possible? No, that's 0. V is y cube. U prime is differentiate 4x partially with respect to s, which is allowed. That's 4. So do you understand that? So then the correct answer to this one is 6x plus. This one is 0. What do I have left? 4y cube. Hence, my final answer for del square g over del x square is 6x plus 4y cube. Or you write it as 2 is common. I have 3x plus 2y cube. So anyhow you want it. Next question, that is C. The next question here says that we should try C. Question says find del square g, del square g over del x del y. Trivially, from the properties of partial derivative, we can write this del square g over del x del y as this. That is, you pick del x first. Then you know that this one have a square. You now pick the next one to be del y. So I can decide to pick del x first. So whatever I have left now will be del. So at this times this will give me del square. Del. So whatever I have left will be del y of what? Of g itself. Do you understand now? So this and this are still the same thing. So this is telling me that I have del x of this result. And I have done this before. It's not part of the question, but I've actually solved it. Del g del y. Remember that del g del y, what I got was, see the result here. Del g del y, I end up having this result. 6x squared y squared minus 6y minus 12. So whatever I want to do now is to divide this thing partially with respect to what? With x. And that will be, this is product rule. So you know what to do. Differentiate this first term, and that's product rule. I always tell you to use product rule. Write it out first so that you'll be able to follow up. So this is what I have. Next thing is minus. Differentiate 6y partially with respect to x. Not possible. 0. Differentiate a constant partially with respect to it. That's 0. So now all we have left is just the product rule. This is my u and this is my v. Now let's interpret. Write out your u. That's 6x squared. Differentiate v partially with respect to, the question is coming from x. So differentiate y squared partially with respect to s. That's 0. You should know that. So, and then plus v is y squared. Differentiate u prime. This is u prime. This is u itself. Differentiate u partially with respect to what? With x, which is allowed. That's 12x. Do you understand that? So that's how it works. Then final answer is this one becomes 0. I will end up having just 12xy squared. So therefore, the second derivative of g partially with respect to both x and y, the result is what? 12xy squared. Do you understand that? But okay, what if I decide to pick y first and dx is there? What do you think is going to happen? Let's try that. It's not part of the question, but let's just try it to see how it looks like. Suppose we now have, let's asterisk this, then we have, suppose we now have del squared g over, the question now comes in form of del y del x. Let's see how this works, whether we get the same answer or not. So this implies picking del y first, and then whatever you have left will be del g over, you have del x left, right? So I have del y, del g del x. That should be, we have it already. This question, this is the first question given to us. And we end up having this result. 3x squared plus 4, 3x squared plus 4y, 4xy cube rather, 4xy cube plus 11, then plus 11. So let's confirm whether we get the same answer or not, to see how it looks like. So from here, we can easily say that I want to differentiate 3x squared partially with respect to y. No y to differentiate, that's 0. Okay, partially. So now here in this case, I have product rule. This would be my u, and this would be my what? V, right? So all I told you to do, I used to tell you that I should use uv prime, write it out, plus vu prime to avoid mistake. Then plus differentiate 11 constant with respect to y, that's 0. Next thing to do from here is to apply the product rule on this term. So u remain as 4x. V prime means differentiate this v that you have, which is y cube, partially with respect to y. So it's possible. And that would be what? 3y squared, right? So 3y squared, right? So then plus v is y cube, and then u prime means differentiate this 4x with respect to y, which is not possible, 0. So hence we end up having 4x times 3y squared. 4x times 3y squared. What would that give you? That will end up giving us 12x y squared. So my question is, the result we have here and the one we have previously, as you can see, let's relate. Let me try to reduce the size. As you can see, d squared g ds dy, see what I got. After trying to swap this down parts, we still have the same answer. Hence, we can easily make a conclusion that, please take note of this. There's a theorem, I think Clairaut's theorem states this. It states that del squared g over del x del y is equivalent to del squared g of del y del x. No matter how you solve, you still end up getting the same answer. So this is how it works. So I think we have one more question to solve. This is the D part. We have one more question to solve. That's the D part. The D part says find del squared g over del y squared. So you can do this as an assignment or as a take home. But let's just try it together. That will be del over del y, then pick del g del y. Pick one of this and pick one of this, see it outside. Then you'll be left to just del del y left. So this thing simply implies del del y of, we already have this result, del g del y. The result is there. Okay, we end up having 6x square y square, 6x square y square minus 6y minus 12. So we want to differentiate this first term. As you can see, it is product rule. Call this one your u, call this one your v. Okay, so that will be uv prime plus vu prime. So I'll come back for this one. Differentiate minus 6y with respect to y. That's minus 6. Yes, it's allowed. That's minus 6. Then constant, that's 0. So in continuation, we end up having uv prime. The u that I have here from this term here is 6x squared. Then v prime is differentiate this y squared with respect to y, and that's 2y plus this v we have here is already y squared, and u prime means differentiate 6x squared with respect to this y, which is not possible. That's 0 minus 6. So therefore, we end up having 12x squared y plus 0. 12x squared y plus 0, and that's okay. This is what we have left. Plus 0 minus 6. We have minus 6. Plus 0 minus 6. So, and then finally, del square g over del y square is what? 12x squared minus 6. So, my final conclusion is, can we say that del square g over del y square is equals to del square g over del x square? Are they equal? I think we just solved this one now. And I think we actually solved the one with partially with respect to x before. So let me just quickly look for that. Okay, I have it here. Let's see, I have it here. Trivially, del square g with respect to the second derivative of g with respect to x, partially with respect to x, we have this result. Now this time around, by the time we differentiate it partially with respect to y twice, we have 12x squared y minus 6, but this one is 6x, so they are not equal. This one is not equal. But remember that I said this square g over del x del y is always equals to what? Del square g over del y del x. So this will be our final conclusion. Please take note of this. With this explanation, I'm very sure you'll be able to solve any question based on partial derivatives. So guys, remember to subscribe to my YouTube channel, and so that you'll be able to get notification on any of my new uploaded videos. So thanks for watching. Thank you very much.